The last lesson in exponents and scientific notation. This is module 4, lesson 4.6. We are now going to compute with scientific notation. So, learning target, I can perform computations with numbers written in scientific notation and the vocabulary. We still are talking about scientific notation and standard form. So we are going to do certain problems where we have operations that are involved in multiplying, dividing, adding, subtracting numbers in scientific notation and how we are supposed to do that. And as we can see, that scientific notation has basically what it has all these exponents, right? So because we have exponents, you may need to multiply, divide these numbers because you have scientific notation in the real world problems. And since numbers written in scientific notation contain exponents, sometimes the laws of exponents can be used when operating with them. And we've already done this, I think, 2 or 3 lessons back. And so we are going to be using the laws of exponents. All right. And when performing, it's also important to know with all operations it is often helpful to write the numbers in the same form, scientific notation or standard form, before computing. So when performing these operations with numbers written in scientific notation, remember that in multiplication use the product of powers property, and in division, please use the quotient of powers property. And again, we've already done this in an earlier lesson. Is saying that scientists estimate that there are over 3 and 5/10 times 10 to the 6th power ants per acre in the Amazon rainforest. If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants. Write in scientific notation. So, the first thing that we are going to do is write the number of acres in scientific notation. So, if I say 1 billion, okay, that means 1 times 10 raised to the ninth power, because you know how many zeros there are. So 1 times 10 to the ninth power, and that's how I'm going to write it out. And then next I'm going to multiply to find the total number of ants. Okay, so we have 3 and 5/10 times, so now I'm going to do my multiplication. I have 3 and 5/10 times 10 to the 6th power. Okay, and I have times 1 times 10 to the ninth power. Okay, and so then I'm going to use the commutative and the associative properties, and I am going to group these two together and these two together. Okay, so I am going to do 3 and 5/10 times 1. Okay, times, I'm going to put the exponents together. 10 and 6/10 times 10 and 9/10. And we are going to multiply 3 and 5/10 times 1, and I'm going to get 3 and 5/10 times 10 to the 6th power times 10 to the ninth power. Okay, now I'm going to use the product of powers property, and that basically means I am going to take my tens, and the product of powers property tells me if I'm multiplying like this, I am going to add the powers. Okay, so what do I get? I get now 3 and 5/10 times 10 to the, what is 6 plus 9? We are going to add those exponents. You get 10 to the 15th power. So the total number of ants is approximately 3 and 5/10 times 10 to the 15th power, because it said to leave the answer, write the answer in scientific notation. So this is my final answer. Okay, so let's do another one really quick, um, with multiplication. And let's say I have this question and say me one dime is, so the dime is how much? It is 1 and 3500 times 10 to the power of negative 3. What would be the height in meters of a stack of 1 million? Million means there are 6 zeros, right? So we're going to do multiplication. 1, and I'm writing that in scientific notation, times 10 to the 6th power. Okay? And so now again, using commutative and associative properties, I'm going to do the grouping, and I am going to do 1 and 3500 times this one times 10 to the negative third power times 10 to the 6th power. 100 times 1 gives me 1 and 3500 times, using my properties of using my product of powers property, I am going to do 10 to the negative third plus 6. And then when I'm seeing these are opposite signs, okay, so I'm left with 1 and 3500 times, what is 6 minus 3 is 3. So 10 cubed and meters. Okay, so this is my answer in scientific notation. Now let's so this was with multiplication. Now let's go on into division. So neurons are cells in the nervous system that process and transmit information. An average neuron is about 5 times 10 to the power of negative 6 meter in diameter. A standard table tennis ball is 400 meter in diameter. About how many times as great is the diameter of a ball than a neuron? And write your answer in scientific notation. Okay. So first what we're going to do is we're going to write the numbers in the same form. So I am going to change this to scientific notation. Okay, so what is 400 in scientific notation? All right, so I'm going to go 1, 2 to the right. Since I'm going to the right, it's going to be a negative exponent, right? So this gives me 4 times 10. And how much did I go to the right? I went 2 to the right. So negative 2. Okay, and then we're going to divide the diameter of the ball by the diameter of the neuron. So if I'm doing that division, I have 4 times 10 to the power of negative 2 over 5 times 10 to the power of negative 6. So next we're going to do the associative property, and we are just going to group this part together and then this part together. Okay, so this means I am going to just group this part together, and I am going to group this part together, the exponent part together. Okay, and then I'm going to, what is 4 divided by 5? I'm going to get 8/10. Okay, so if I divide this, I get 8/10 times. Okay, so now let's look. I'm going to use the quotient of powers property. Quotient of powers property tells me that if I have this, okay, I am going to subtract this one that's coming up, and this becomes minus 6. Okay, so now I have 8/10 times 10. Removing negativity gives me positivity, or we know that we add the opposite. Okay, we've done that before. So this is -2 plus 6. And now we have opposite signs. Okay, so what am I left with? I'm left with 8/10 times 10. 6 minus 2 is 4. 10 to the 4th power. Now, here's the thing. Is this in scientific notation? No, it isn't, because we need to see that the decimal needs to move one place to the right for it to be in the scientific notation. So if I am moving one place to the right, you're going to move the decimal place to the right and subtract 1 from the exponent, right? So this becomes 8 times 10 cubed. And this is my answer in scientific notation. And if I was writing this in standard form, the diameter of the table tennis ball is about, so from the scientific notation, which is 8 times 10 cubed, to standard form, which is 8 times 1,000, that means 8,000 times 8,000 times larger. And this would be the standard form. Okay, larger than the diameter of the neuron. So this is how we do our calculations with division. Let's do another division problem really quick. And let's do this one. Okay, so find 1 and 5/10 times 10 to the power of -8 over, and the fraction line obviously means division, over 6 times 10 to the 7th power. Okay, so we are going to again rewrite as a product of fractions. All right, so if I have this, I am going to do, again, group it, this times this. Okay, so I'm going to group it like this. And after that, I am going to divide 1 and 5/10 times 6. And so I end up with 2,500. So when I divide 1 and 5/10 by 6, I get 2,500. All right. And then I'm going to do times. Let's look at this one. I'm going to do 10 to the power of -8. Okay. Minus 7. So I'm using the quotient of powers property over here. So when I do this, I'm going to get 2,500 times same signs. So I'm going to add them, and I get -15, because 8 plus 7 is 15, and the sign in the front is the negative sign. And then I can see that 2,500 is not written in scientific notation form. So in the sense that I've got to move this one, right? So if I am moving it to the right one, that means I am going to add on 1 to the power, and this becomes -16. Okay, and this is again the powers of product of powers property being used at the end. So here we go, and this is how we get our answer when we are dividing. Okay, so to add or subtract numbers written in scientific notation with the same power of 10, add or subtract the factors. And when the numbers have different powers of 10, you're going to first rewrite the numbers so that they have the same power of 10. And to multiply or divide numbers written in scientific notation, multiply or divide the factors and powers of 10 separately. Okay, so let me show you this. And I'm just going to pull this down already so that we also have a question over here. Okay, so let's look at this. All right. So to add or subtract numbers written in scientific notation, it is helpful to rewrite the numbers so that the exponents on each power of 10 have the same value. Okay. So look at the first. Okay. To add 3 and 6/10 times 10 to the fourth power to the numbers shown. Okay, what you need to do is that you will need to, each number needs to be rewritten so the exponents on each power of 10 are the same. So let's look at those examples up there, and I'm going to rewrite them so that those all of them have the same power, where it is saying times 10 to the fourth power. Then it becomes easy for me to add, subtract. Okay, so if I was to change 1 and 4300 times 10 cubed to 10 to the fourth power, so that basically means what? For me to have to the fourth power, the 10 cubed to the fourth power, that basically means I would have had to go back one, right? So what would this number be then? This one would have been 143,000. Okay, 143,000. Let's look at the next one. So if I had 1 and 4300 times 10 to the fifth power, and I'm trying to make it to times 10 to the fourth power, so then in that case, I would obviously have to move to the right one. So I would have to do this. Then that would become to the fourth power, right? So this would be 14 and 3/10. Let's look at the last one. I have 1 and 4300 times 10 squared, and I'm trying to make it 10 to the fourth. So for that, for it to happen, it has to go two more to the left, right? And so I would have this number, 0143. And then only when, I can see I've converted them all to the same format, then you can easily add or subtract using the distributive property. Okay, so let's say I have this question given to me over here. I have 4 and 3600 times 10 to the fifth power, plus 2 and 900 times 10 to the sixth power. So what I'm going to do is I'm going to change them both to exactly the same format. So I'm going to change them both to 10 to the fifth power. So the first one is already in the correct format. So I am going to rewrite with the same power of 10. So I'm going to take my first one, which is 4 and 3600 times 10 to the fifth power, plus I am going to rewrite this and I'm going to move this 1. So this becomes a 5. Does that make sense what I just did? I changed that 6 to a 5 because that is the best way for me to add or subtract. So I just wanted to show you what I'm doing over here. So, okay, here we go. So this becomes 20 and 9/10 times 10 to the fifth power. So I've moved the decimal 1 and then I have brought the 6 down. So the 10 to the 6th, remove the 1 because I moved to the right. This becomes 10 to the fifth power. Okay, that's what I've done because I'm trying to rewrite with the same power of 10. And then I am going to use the distributive property. Okay, and we have addition going on over here. So let me go ahead and I am going to take both of these numbers and I am going to group them together and then I multiply with the same power of 10. So, okay, so here we go. I'm going to do 4 and 3600 plus 20 and 9/10, right? And times 10 to the fifth power. And this is where my distributive property is coming in. Okay, so now all I do is I add 4 and 3600 and 20 and 9/10, and I'm going to get 25 and 2600 times 10 to the fifth power. For scientific notation, my decimal has to be behind the first digit. So we move 1 to the left. And when I do that, I am going to rewrite it. And this is good. Since I'm moving 1 to the left, this is going to be added on 1. Okay. And so I end up, my final answer is 2 and 526,000 times 10 to the sixth power. Okay, so this is my final answer of adding. So remember to always change the 10 raised to a certain power to the same power, and then after that it becomes very simple to compute. Let's do one last. So here's the last example in this lesson, and I am going to add or subtract with scientific notation, and these are the numbers that are given to me. All right. And we have 1 and 4500 times 10 to the ninth power minus 2 and 8400 times 10 to the eighth power. Express the result in scientific notation. So I'm going to go ahead and I am going to convert them both to 10 to the eighth power. So if I'm going to like change them both to the same notation, that is going to be helpful. So in order for me to change this to 10 to the eighth power, I will move 1 to the right. And when I move 1 to the right, this becomes 14 and 5/10 times 10 to the eighth power minus, we already have that, 2 and 8400 times 10 to the eighth power. And now we are going to use the distributive property. Okay, and we are going to take 14 and 5/10 time minus 2 and 8400 times, you can either write this because I have to show it, otherwise just 10 to the eighth power outside, and that would signify my distributive property. And then I'm going to subtract 2 and 8400 from 14 and 5/10, and I'm going to get 11 and 6600 times 10 to the eighth power. And then for scientific notation, I'm going to write in the scientific notation form. That means I have to move this 1 to the left, and I get 1 and 166 thousandths times, because I moved 1 to the left, you're going to add on 1 over here, and that becomes to the ninth power. And so this is my final answer for computing, adding or subtracting. In this case, it was subtraction. All right. So the most important things again to remember when we are computing, if you're adding or subtracting, make sure that you are changing them to the same power of 10. And then when we are multiplying and we are dividing, use the product of powers property or use the quotient of powers property in order to compute with scientific notation in order to solve it. Okay. And that concludes module 4, which is all about exponents and scientific notation. Have a great day, everyone.